So welcome to the first help video for our Chapter 9 quiz. Again, these are not the answers for your quiz, but these should help you figure out how to make the corrections to your quiz and the correct adjustments that you need to do. So this is for section 9.1, identifying quadratic functions. First thing you are asked to do is to decide whether an equation represents a quadratic function. So let's look at these two that I have on my page right here. Y equals 3x plus 5 and y equals 3x squared plus 5. The big thing that you want to look for is this squared deal up here on the second equation. If the biggest exponent in your equation is a 2, meaning it's not a 3 or a 4 or 5, or a 1, or as in the first equation, it's not written there, so we know it's a 1. If the biggest exponent is a 2, then it is quadratic, as long as we aren't dividing by x somewhere in there. Okay, so there are some other rules that'll come into play, but for this class at this time, that's the biggie you got to look for. Not dividing by x, and then also the biggest exponent is 2. All right. The second thing you are asked to do is to use the picture to the right, this graph of a parabola, to answer some questions. So first one is identify the coordinates of the vertex. Now a vertex will be either the bottom or the top of a graph. Now this graph doesn't show it, but this goes on forever on the top and bottom. On the top, which means there is no maximum to this. There's no vertex. It never stops going up, but there is a bottom right here. And the coordinates for that, we go -3 in the x, -3, -1, 2, 3, and -1, 2, 3, 4. This is at -4 in the y. So the coordinates of the vertex are at -3, -4. Is this vertex a maximum or minimum of the function? Well, this is where the function bottoms out. It's the lowest point, okay? This is the lowest, which means this is a minimum, okay? So I'm going to go ahead and write minimum here. Now, what would this look like if it was a maximum? Well, that would be a situation where the parabola looked like this, and the vertex would be at the top, and that would be a maximum. But that's not what we're dealing with here. Okay, that's not what we're dealing with. And the last part is, what is the domain and range for the function? Well, the domain has to do with which x values show up on the graph. Now, for all of our quadratic functions in this class, we will not have any restrictions on the domain. The domain is going to be all real numbers. All right? And what that means is that I can put in any value for x that I want, and there will be a y that goes along with it. For instance, -3 goes with -4. -1 goes with 0. 0 goes with 5. Any x that I put in, there will be a y that goes along with it. Now the part we have to remember is that this graph goes on and on forever, and that can be a little bit misleading because it looks like it stops, but it doesn't. Now the range has to do with the x's. So range has to do with the y's. Remember, the domain has to do with x. And then the range has to do with the y values. Now as I look here, the lowest y value is at -4, and then from there it goes up. Okay, so we start at -4 and goes up. So the way I'm going to write this is that the range are the y values greater than or equal to -4. Now, if this graph went the other way, if this graph was something that looked like this instead, that means that I would start at -4 and head down. So this sign would be switched around, be the y values less than or equal to -4. But that's not the case for us. Okay? All right, so that is our first section for 9.1. I hope that helps you.